Hello, friends. Are humans the only intelligent species in the universe, or are there other intelligent beings somewhere? If aliens really exist, it's natural to wonder if perhaps they ask similar questions. Are they alone in the universe? And how could two intelligent species even communicate with one another? With these questions in mind, NASA has undertaken numerous projects to send messages to potential extraterrestrial civilizations. In 1977, NASA launched the Voyager 1 spacecraft on a mission with a clear objective: to explore our solar system, including its outer planets, the far reaches of the Sun's influence, and beyond. In simpler terms, it was an interstellar mission. Our Milky Way galaxy alone contains millions of solar systems, separated by vast stretches known as interstellar space. To date, NASA has launched only 5 interstellar spacecraft: Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. Only 2 of these, Voyager 1 and Voyager 2, have reached interstellar space, as it takes an extremely long time to journey beyond the solar system. These 2 Voyagers are particularly special. They explored our solar system, capturing stunning images of Jupiter, Saturn, Uranus, and Neptune. Voyager 2 is still the only spacecraft to have flown close to Uranus and Neptune, while Voyager 1 holds the title of the farthest man-made object from Earth, at a distance of 24.7 billion kilometers as of October 2024. What's especially fascinating about the Voyager probes is that they carry messages intended for extraterrestrial life, traveling through space in hopes of one day encountering alien civilizations and sharing a glimpse of who we are. We step out of our solar system, into the others, is one of the messages aboard. But what exactly is in these messages? And what story is NASA hoping to convey about humankind? The story of the Voyager missions begins in 1965 when a NASA engineer observed that the outer planets, Jupiter, Saturn, Uranus, and Neptune, would align in a unique configuration in the late 1970s, an event that only occurs once every 175 years. This alignment would allow a spacecraft to take advantage of each planet's gravitational pull, reducing the need for fuel and shortening travel time. This principle, known as gravity assist, uses the mass of a planet to alter a spacecraft's speed and trajectory. Based on this principle, NASA planned the Voyager 1 and Voyager 2 missions, choosing 1977 for their launch to leverage the planetary alignment. Voyager 1 was tasked with flybys of Jupiter and Saturn, with special attention to Saturn's moon Titan, while Voyager 2's journey included close encounters with Jupiter, Saturn, Uranus, and Neptune. Both spacecraft were designed similarly, powered by 3 radioisotope thermoelectric generators, RTGs. Unlike other missions, they didn't rely on solar panels, as sunlight becomes too weak to generate sufficient energy beyond Mars and Jupiter. Instead, their RTGs generate power through the radioactive decay of plutonium, converting the released heat into electricity. Each Voyager also carries 10 scientific instruments: an imaging system for photos, a spectrometer for hydrogen analysis, another spectrometer for ultraviolet activity, a magnetometer to measure planetary magnetic fields, a high-gain antenna for communication with Earth, and other instruments for measuring radiation levels. Interestingly, Voyager 2 was launched first on August 20, 1977, while Voyager 1 followed 16 days later on September 5. Although launched second, Voyager 1 took a shorter, faster route, reaching Jupiter first and capturing an extraordinary time-lapse in March 1979. This time-lapse, made from 66 photos taken after each rotation of Jupiter, which rotates every 10 hours, provided the clearest view of Jupiter and its moons to date, revealing even Jupiter's faint rings. Many people think Saturn is the only planet with rings, but Jupiter too has rings, though they're hard to see from afar. Jupiter, its moons, and its rings together make up what's called the Jovian system, named after the Roman god of sky and thunder, Jove, also known as Jupiter. In fact, 3 other planets in our solar system resemble Jupiter: Saturn, Uranus, and Neptune. Each of these gas giants has rings and multiple moons, earning them the collective name of Jovian planets. Giant, Jupiter-like planets. During its exploration of the Jovian system, Voyager 1 also discovered ongoing volcanic activity on Jupiter's moon Io. The Voyager mission marked a monumental moment in human space exploration. For the first time, humans observed active volcanoes on another planet and discovered that Jupiter had more moons than previously thought. Before Voyager 1's arrival, scientists believed Jupiter had 13 moons, but Voyager 1's closer examination revealed 2 additional ones. Then, in July 1979, Voyager 2 reached Jupiter and discovered yet another moon, bringing the count up to 16. Today, however, we know that Jupiter is surrounded by 95 moons. On November 12, 1980, Voyager 1 arrived near Saturn, moving even faster than Voyager 2, which took an additional 9 months to reach the same destination. During this time, Voyager 1 discovered Saturn's moons Atlas, Prometheus, and Pandora. Interestingly, Pandora shares its name with the fictional alien planet in the movie Avatar, although in reality, it's one of Saturn's moons. Back then, Saturn was thought to have only 15 moons, but today we know there are about 146. Among the photos captured by Voyager 1, Saturn's moon Titan is particularly fascinating. Titan is the only other celestial body, besides Earth, where large quantities of liquid water are known to exist. This unique quality has inspired countless science fiction stories where Titan serves as a possible home for aliens or even a new world for humans. After Saturn, Voyager 1 and Voyager 2 took different paths. Voyager 2 continued toward Uranus and Neptune, becoming the first and only human-made object to visit these planets, capturing iconic photos in 1986 and 1989, respectively. Voyager 1, on the other hand, left the ecliptic plane, an imaginary plane on which most planets orbit the Sun, using gravity assist to accelerate to over 60,000 kilometers per hour. On February 14, 1990, Voyager 1 captured the famous pale blue dot photo from about 6 billion kilometers away, a family portrait of the inner solar system. Following this, its cameras were turned off to save power as it ventured into the darkness of interstellar space. In 1998, Voyager 1 became the farthest human-made object from Earth. By 2004, it crossed the termination shock, a region at the solar system's edge where the solar wind drops significantly. The solar wind, a stream of charged particles emitted by the Sun, creates a protective bubble known as the heliosphere, shielding us from interstellar radiation. Beyond the heliopause, the heliosphere's outer boundary, Voyager 1 entered a boundary-free diffusion zone where solar and interstellar winds blend. On August 25, 2012, Voyager 1 finally entered interstellar space, a milestone confirmed by a powerful solar eruption that caused nearby electrons to vibrate. NASA later announced in September 2013 that Voyager 1 had indeed exited the solar system. The Voyager missions not only broke records but also carried messages for potential alien civilizations. Before them, Pioneer 10 and 11 carried similar messages on small golden plaques. However, the Voyagers contain more detailed information on 12-inch gold-plated copper discs, called Golden Records, with sounds and images from Earth, including greetings in 55 languages and music from various cultures. The Golden Record even includes images of basic mathematical, chemical, and physical concepts, as well as diagrams of human anatomy and DNA structure. NASA's goal was to represent humanity's scientific and cultural knowledge, albeit in a form that aliens might struggle to interpret due to the complexity of the instructions for playing the phonograph records. The Golden Record attempts to showcase humanity's positive side by avoiding depictions of war or conflict, focusing instead on our advancements and the beauty of life on Earth. While Voyager 1 continues its journey through interstellar space at over 61,000 kilometers per hour and remains approximately 25 billion kilometers from Earth, its power supply is expected to deplete by 2025, which would end our communication with it. However, the Golden Record will remain on board, preserving a message from Earth for eternity. Whether any alien civilization will ever find and understand it remains an open question. Thanks for joining us on this journey beyond Earth. Here on Eye of Cosmos, we explore the mysteries and wonders of space, bringing you closer to the unknown. Don't forget to subscribe for more cosmic stories and discoveries.